Welcome to this video on the Jahn-Teller effect, also known as the JT effect, which causes distortion in coordination compounds.
The Jahn-Teller effect explains why certain coordination complexes exhibit distortions instead of perfect geometry. This phenomenon occurs in octahedral or tetrahedral complexes, where electronic degeneracy leads to system instability.
The Jahn-Teller theorem states that any nonlinear molecule with a degenerate electronic ground state will distort to remove degeneracy and lower its energy. In simpler terms, unequal occupancy of degenerate orbitals causes molecular distortion. Let's consider an example: the octahedral D9 system of Cu2+, specifically CuH2O6 squared. Its electronic configuration is T2G to the power of 6 Eg cubed. The Eg orbitals are degenerate, but their uneven electron occupancy leads to instability. To relieve this, the complex undergoes tetragonal distortion, either elongation or compression along one axis. There are two main types of distortion. Axial elongation occurs when metal-ligand bonds along the z-axis lengthen, common in D9 systems like CuH2O 6 squared. Axial compression, though less common, involves the shortening of metal-ligand bonds along the z-axis, observed in some D4 high-spin systems. Significant Jahn-Teller effects are observed in electronic configurations such as D4 high spin, D7 low spin, and D9 Cu2+. Conversely, the effect is weak or negligible in D3, D5 half-filled, and D10 fully filled configurations. In real-life examples, CuH2O6 squared shows axial elongation, while Mn3 ACAC3 exhibits distorted octahedral geometry due to its D4 configuration. Na3 N3 also displays slight distortion to relieve degeneracy. These distortions can be detected experimentally using spectroscopy and X-ray analysis. In summary, the Jahn-Teller effect removes electronic degeneracy through geometric distortion, commonly observed in octahedral complexes with D4, D7, and D9 configurations. This process leads to the elongation or compression of metal-ligand bonds, ultimately stabilizing the molecule by lowering its overall energy.